All right, let's talk about building software. We're going to dive into a story about speed, security, and this constant, relentless push to build better software and to do it faster. It's really a journey from what used to be a long, straight road to a tiny, supercharged, repeating loop. So let's get into it. And this, right here, brings us to the core question of this entire explainer. For, decades, we've treated security as something you do at the end. A final check before you ship. But in a world that moves at the speed of code, does that even work anymore? Is security a final hurdle you have to jump over? Or should it be the powerhouse that's driving the whole process from the start? To even begin to answer that, we've got to go back to a really basic problem. Building software is, well, it's incredibly complex. And without some kind of framework, it can just spiral into total chaos. So the fundamental question has always been, how do you bring order and some kind of predictability to something as creative as innovation? Well, the first big answer to that question was the Software Development Lifecycle, or SDLC for short. Just think of it as the master blueprint for everything. It's a structured process that lays out all the phases that software goes through, starting from the very moment an idea pops up, all the way until it's finally retired. And this blueprint, it has some really distinct stages. You always start with planning and analysis. What are we building? Then you move to design, and after that, the actual development, the coding. Then comes testing, of course. Then you deploy it for people to actually use, and finally, you're in the maintenance phase for the long haul. Pretty much every piece of software you've ever used has gone through these phases in one way or another. So the very first attempt to formalize this whole thing was something called the waterfall model. And the name is perfect because it really was like a cascade, a total one-way street. You had to completely finish one phase, like planning, before you could even think about starting the next one, like design. It was super rigid, very predictable, and very, very linear. But here's the thing. There was a huge, fatal flaw. The real world just isn't that linear, right? Business needs change, customers change their minds. The problem, like this quote gets at, is that if your software is only ready at the very, very end of this long road, you have zero room to adapt. If a requirement changed halfway through, you can just tweak things. Nope. You often had to go all the way back to the beginning. Ouch. And this problem, it basically created two totally different ways of thinking about building software. On one side, you have the predictive models, like waterfall, where everything is planned out in excruciating detail up front. The scope is locked in, the documentation is massive. But on the other side, you have adaptive models, which totally embrace change. They just assume requirements are going to evolve, and they use only the minimum amount of documentation to get the job done. And this adaptive way of thinking gave birth to Agile. And man, did it change things. Instead of one long 6-month or even year-long journey, Agile broke that process into these small, repeatable cycles called sprints, often just 2 weeks long. And in each and every sprint, you'd build and deliver a small working piece of the software. This right here was the first great shrinking of the loop. Okay, so Agile is great, right? Problem solved? Well, not exactly. It actually created a new problem, a new bottleneck. Your development teams were now cranking away in these fast 2-week sprints, but the operations teams, the folks who actually deploy and run the software, they were still stuck working in these slow monthly or even quarterly cycles. All that friction gave rise to a new movement, which, as you can see, really kicked off around 2009, DevOps. Now, DevOps wasn't just a new tool you could buy, it was a full-on cultural shift. It was all about breaking down the walls between the development and operations teams through better communication and collaboration. And it was powered by a ton of automation, automating everything from building the code, to testing it, to deploying it, and then monitoring how it's all working. This is what let those Agile loops run even faster than before. But all this focus on speed, shipping features faster and faster, well, it came with a price. A big one. In the massive rush to deliver, one absolutely critical group was often forgotten, just left out of the loop completely: the security team. Security was still seen as that slow, final checkpoint at the very end of the road. And this is where things got kind of personal. It created what you could call a trust problem, this deep divide. On one side, you had developers who saw the security team as these gatekeepers, right? The Department of No, just a bunch of blockers who slowed everything down. Meanwhile, the security team was looking at developers and just seeing them churn out vulnerable, crappy code without any thought about the risk. And the root of this isn't malice. It's really what Hassan Yassar from Carnegie Mellon points out here. It's a fundamental gap in training and priorities. Developers are paid and rewarded for building features and shipping code. They aren't security experts. And on the flip side, security experts aren't trained coders. They were basically speaking two completely different languages, with two totally different goals. So what's the solution? You guessed it, shrink the loop. Again, but this time you bring security inside that loop. The whole idea of DevSecOps is to stop treating security as this final inspection gate and instead to embed it, to weave it in as an integral, automated part of the entire development and operations process. And does it work? Oh yeah. The results are, well, they're pretty staggering. For organizations that have already figured out DevOps, the ones with all the automation and collaboration already in place, adding security into that process makes them 338% more effective. That is not a typo. It just goes to show that once you've built that high-speed engine, making it secure isn't just possible, it's actually incredibly efficient. The whole philosophy behind DevSecOps can be summed up in two words: shifting left. I want you to picture that SDLC timeline we talked about, going from left to right. Shifting left literally means moving all those security activities from the far right end, right before release, and pulling them all the way over to the earliest possible stages on the left. So, what does shifting left actually look like in the real world? Well, it's not just one thing. It means doing threat modeling way back in the design phase before anyone's written a single line of code. It means using automated tools that give developers security feedback right inside their editor while they're coding. It's about automating security tests, like static analysis or SAST, which checks your code before it runs, and automatically validating configurations before you deploy. It's about putting security everywhere. Okay, great. So you've done it. You've built this incredible, high-speed, secure development loop. It's working beautifully. But now you've got a new challenge. How do you manage this thing? More importantly, how do you prove to your customers, to your board, to regulators that you are, in fact, secure? This is where we shift from the hands-on practice to high-level governance. And a key standard here is something called ISO 27001. Now, look, I know what you might be thinking. Standards, but hang with me. The really crucial thing to understand is that this is not a technical checklist. It's a management system. It gives you a complete framework, a blueprint, for how your organization should manage its people, its processes, and its technology to systematically protect all of its information. Now, it's also really important and really easy to get this confused with its sibling, ISO 27002, so let's clear that up. Just think of it like this. ISO 27001 is the shall document. It lays out the mandatory requirements you shall meet, period. ISO 27002 is the should document. It's a guide full of best practices that tells you how you should go about meeting those requirements. One is the what, the other is the how. And what do you find at the very heart of ISO 27001? You guessed it, another loop, the plan, do, check, act cycle. It's so simple. You plan your security system, you do it, implement and operate it, you check to make sure it's working, and then you act on what you found to improve it. It's a cycle of continuous improvement that perfectly mirrors the iterative nature of modern software development. See how it all connects? So when you step back and look at the whole story, from that long, rigid road of waterfall to these tiny, self-improving loops of DevSecOps, the main takeaway is crystal clear. Speed and security are not enemies. They don't have to be opposing forces. When you integrate them properly, they actually reinforce each other, creating a process that is both incredibly fast and inherently strong. But, this evolution, it never stops. Today, we're facing a whole new wave of change with AI getting baked into software development, which is creating amazing new opportunities and scary new threats. So the final question is this. You've built a fast, secure loop for today, which is great, but is your process adaptive enough for the challenges of tomorrow? Because that is the loop that never, ever ends. Thanks for listening.